Hello, happy week 3. We're here. We're getting ready to do more math. I hope this is all going well for you guys. I feel like I haven't really seen a lot of geometry students in office hours, just like one or two. Um, so hopefully this is just making sense. That's what I'm hoping is happening. With that, I'm going to give you a little bit more surface area practice this week as well, just because I know from experience that surface area tends to be one of those things that's a little bit tough. And I didn't get a lot of questions on it last week. I kind of thought I would, and I didn't. But I'm just going to go with my gut here and trust that maybe we need a little bit more practice on it. So we'll do a little bit more of surface area, but ultimately we're going to start volume, which is what these notes are about. And then we're going to spread volume out over this week and next week, and then kind of move on from there. So let's jump into it then. Today we are on page 32. Volume of prisms first is what's going to be our first focus. So the volume of a prism. The best way to think about the volume of a prism is to think about finding the area of one part, the base of the prism, and then to take that one part and continue to repeat it over and over and over again. A good example of this is think about a loaf of bread, right? And I drew a picture here that's kind of my best rough sketch of a loaf of bread. In case you didn't know, I'm not an artist. Yeah, I tried. They kind of look like peanut butter and jelly sandwiches with lots of jelly on them. But think about a loaf of bread, right? That first piece is your base. And if you took the area of that first piece, and then you could repeat it for every single piece of bread in there, and then figure out the total area of bread inside the loaf of bread, which we refer to as the volume. The total space inside that entire loaf. The total amount of bread that you're getting, which is never enough. There's never enough bread in the world. I love bread. It's life. Quarantine's making me weird. I'm sorry, y'all. Okay, so here is our formula that we're going to look at. We use the formula volume equals big B times H. Big B, we've already talked about. Big B represents area of the base. It's not base as in one measurement. To find big B, you have to do some sort of an area formula first, then plug that into the volume formula. So you just find the area of the base, and then multiply the area by whatever height of the figure is. So let's jump. I think that brings us to our first example already. Yeah, it does. Great. Great. Let's jump over here. Okay, so my first example is to find the volume of this hexagonal prism, right? So the first thing that we have to find is we have to figure out what is the value of big B. What is the area of the base? Well, in this case, because the base is a hexagon, we have to go back. And I know I didn't give you any practice with this last week, so kind of jog your memories back 2 weeks ago. We did a whole section of notes on area of regular figures that are not quadrilaterals or smaller, less sides. So it was anytime you have a shape that's 5 sides or more, we use the formula area equals 1/2 apothem times perimeter, AP, 1/2 AP. So we can just kind of figure that out from there. We know that if we look at this hexagon, the apothem is 4 feet. I drew it up here to kind of make a little bit more sense of it. So the apothem's 4. The perimeter, well, if this side's 2, we know this side's 2, this side's 2, this side's 2, 2, 2, 2. So you got 6 2's. So 2 times 6 times equals 12. So the perimeter is 12 feet. So I'm going to put 12 here. So ultimately, my area is going to equal 1/2 of 4, which is 2. 2 times 12 is 24. So my area is 24. Okay. So now we can come over and do the volume side, which is super easy once you know that. Ooh, what? Volume. There. Done. We see the height of the prism. Now, again, be mindful of that. The height of the prism doesn't always go straight up and down, right? It could be that you have a hexagon that's sitting like this and goes this way, right? The height then is going to be this length right here. Height just represents the distance between the two bases. In this case, the height's doing what it's supposed to. It's going straight up and down. But if I knock that prism over, because it's three-dimensional, I can do that, then the height might go sideways. Just remember, height always represents distance from one base to the other base. So I'm going to have volume equals big B, which we said the area is 24, so big B is 24, times the height. Again, this was big B times height. I should have wrote that out. The height is 6. So I have 24 times 6, so volume equals 48, 96, 144. Yeah, 144. And then for our units, we're going to put feet, but this time, because we're talking volume, right? When we're talking area, it's just square units. In volume, it's cubes. It's how many cubes could I fit inside of there? How many cubes of bread are inside of a loaf? So we're going to put feet cubed. A 1 by 1 by 1 cube. And that's it. That would be your volume. Simple as that. So again, jumping back over here so you can write down my nicer version. This is what it looks like. You can see what we're going to do for example 2. Pause that if you need to. Get that copied. Then come back up with me. All right, example 2, we're going to look at finding the volume of a triangular prism. So this is one of those ones where the height kind of gets flipped on me, right? The base here is a triangle. So when I go to find the area of the base, I got to figure out what the base is. Well, in this case, the base is a triangle, a right triangle specifically. And so we got to figure out kind of our measurements. Do we know the hypotenuse length? Well, there's 2 spots to look. The hypotenuse is here, and the hypotenuse is back here. I don't know either of those, so I don't need to write anything down there. But I do see right here that the base across the bottom is 4, so I know that I can put a 4 here. And the height is this part going up, which isn't on the front. But if I look on the back, they do have a height in the back there, and we know that height should be the exact same as the front, so that 5 can come up here as well. And now I can go ahead and find the area of a triangle. So the area of a triangle is 1/2 little b times little h. So it'll be 1/2 4 times 5. 4 times 5 gives me 20. Half of 20 is 10. So I get area equals 10. And as with last time, we just jump over here now and do volume equals big B times h. Well, the volume here, then we're going to have 10 for big B. The height, again, is the distance between the 2 bases. So you see this triangle on the front, this triangle on the back. Well, the distance between those 2 triangles is right here, and it's 10 units. So I'm also going to put 10 for the height here. That is just a coincidence that happened. It doesn't always happen. So 10 times 10 gives me 100. And again, let's put our units, but we're going to put them as cubed. So 100 inches cubed. Done. So again, jump back over here. Go away. Okay, and coming up on this last example then. My last example is this. Determine the side length of a cube given that the volume of the cube is 343 centimeters cubed. Now, remember, we know that a cube is a square, right? It's a square prism. So I've got this, that. That came out super close to good. Okay, so I know that this, and this, those 3 side lengths have to be the same, right? The square on the bottom is x by x, and then the height of the prism is also x. So if you multiplied that, right, thinking of that whole formula, volume equals big B times h. Big B in this case is the area of a square, which is little b times little h, which we just said is x times x, so x squared. And then I know the height of my prism is also x. So big B is x squared. Height is x. Well, x squared times x is going to give me x cubed. So I know the volume of a cube is x cubed. This is also really useful just to remember. Cubes and rectangular prisms, you can also use the formula that you probably learned in elementary school. Length times width times height. Same formula as big B times h. Length times width times height. That's what's happening here. The length times width times the height is x cubed because it's the same. The length, the width, and the height of a cube has to be equal. So what I'm going to do then is, now that I know that I have this formula x cubed, I'm going to set 343 equal to x cubed and solve this. So I take the cube root of that side, take the cube root of this side. Cube roots cancel to give me x, and cube root of 343, you all know that off the top of your head, right? Definitely. I totally didn't use a calculator to know that that was 7. It's 7. I used a calculator. Oh, I should have put units, right? 7 centimeters. And that would be your answer. So again, just to see my rendition of that in my notes. I don't think I explained it as well in my notes, though, if I'm being honest. Move. Oh no, what did I do? What did I do? Don't yell at computers, it doesn't help. Ah! Y'all, technology's killing me today. There we go. So that is the representation I did to solve that. So let me know if you have any questions. Please come see me in some sort of Zoom office hours this week. I'd love to talk to you. Want to help you out as best I can. Have a fantastic day. Bye, y'all.